I'm often asked questions about problem solving and reasoning, so I'd like to share a problem that I think is somewhere about the year 5 level onwards, and all it involves is some basic 2-colour counters. So we've got 4 counters here, and 3 of them are yellow face up and 1 is red face up. And so I'm going to give you a word question that has some problem solving and reasoning in it. So my first statement is a red counter is worth twice as much as a yellow counter. That's statement number 1. So a red counter is worth twice as much as a yellow counter. Altogether, those counters are worth 40 points. That's my second statement. Here's the question. How much is a yellow counter worth? So I'll run that past you again. A red counter is worth twice as much as a yellow counter. Altogether, those counters are worth 40 points. How much is a red counter worth? I'll let you think about that for a moment, and then we'll do part 2 of this video. So let me share a couple of ways of solving this problem. Firstly, I'll make the comment that the answer is 16. Lots of children will put 8. And if they put 8, they're nearly through the problem. They've just got one little extra part to do. So here's one way you might solve that problem. You might use a guess and check method. You might say, well, if a yellow is worth 10, then I'd say that's 10, 20, 30, and that's another 20, because 2 10s are 20. 50, that's too large. So then I might go, well, let's try 5. So that's 5, 10, 15. Another 10's 25, it's too low. So I try a number in between. So let's try 8, 8, 16, 24, and 16 gives me 40. So a yellow counter must be worth 8. Therefore, a red counter is worth twice as much. It's worth 16. Let's look at a different way of solving that problem. If a red counter is worth twice as much as a yellow counter, that means I could swap it for 2 yellow counters. So in other words, what I have is 5 counters have a value worth 40. In other words, how many 5s in 40? So the answer would be 8. Now lots of children would stop at that point, but they need to actually ask, what was the question about? What's a red counter worth? Now what's a red counter worth? Twice as much as a yellow counter. So that means a red counter would be worth 16. There are many ways that we might vary the original problem. Remember I said that a red counter is worth twice as much as a yellow counter. What if I said a red counter is double the value of a yellow counter? So I've changed the language. Or I could have said a yellow counter is worth half as much as a red counter. So just varying the language would be one change that we could make. Another would be, originally we said altogether they're worth 40 points. What if I change that to 20 points or 10 points? Then the calculation part becomes much simpler. In other words, you had to be fluent enough to work out how many 5s in 40 in the first case. But if you didn't know that, how many 5s are in 10 would be much easier. But I could make it even more difficult. What if I said altogether, the points, altogether those counters are worth 1 point? Now we'd have to start working with fractions. So you start to see how we could vary it. Here's another way we could vary it. We could have more counters on here. And so now we have to think about, we've got 1, 2, 3, 4, 5. Remember, red one's worth 2, so we've got 7 counters. So we would choose some multiple of 7, and we'd start to work with division by 7 in order to do this calculation. We've been working through this problem about the 4 counters and looking at variations on it. It might surprise you to know that this was a question that was in the 2014 NAPLAN testing for Year 5s, and only 24% of Australian children in Year 5 could get this correct. What is interesting is we didn't find out how many got an answer of 8, which tells me that they're partway through the problem, but they haven't done Polyer's last step. Now, Polyer is the father of problem solving, and he talks about 4 steps to solve a problem. 1 is to understand a problem, 2 is to devise a plan, 3 is to actually carry out the plan, but the 4th step is about looking back or checking your answer. If you had checked the answer, children would soon realise that they might have worked out 8, but they have to do double 8, 16 to give that answer.